Hello guys, I am Nidhishri S. Pagalwadi, your science teacher, Sankalp Learning Solutions. In the last class, we learned regarding the decomposition reaction, and also we watched a video on the activity which shows the thermal decomposition reaction. So the activity was the decomposition of lead nitrate when we heat it. And also we discussed regarding photochemical decomposition. We also learned regarding the electrolysis, that is decomposition of water using electricity, with the help of electricity. Okay. Today we are going to learn other types of reaction. For that we are going to perform an activity and then we are understanding which type of reaction it is. So let me perform an activity first. For the activity, I need the materials like test tube. I need a chemical named copper sulfate, which will be blue in color. Okay. Then I need iron nails. Okay. So these all are the requirement. Now I am taking a solution of copper sulfate. As you can see, the solution of copper sulfate is blue in color. I took a solution of copper sulfate. Now I am adding the copper sulfate to a beaker, to a test tube. So this is a test tube. Okay, this is a test tube. So the thing is nothing but it is a result of the previous activity which I did for other class actually. So it is clean, actually no reaction takes place. So this is like this, and the capacity will be 10 ml. So now I am adding copper sulfate solution in the test tube. Okay, copper sulfate solution I am adding. So I prepared a very dilute one. So I will make it quite a thicker one. Means I'm adding a few more copper sulfate crystals. So this is a copper sulfate. Okay, this is a copper sulfate. And okay, now when you see the copper sulfate solid, that is crystals, you can see these are blue in color. The crystals are blue in color. So I'm adding quite few crystals so that the blue color is visible clearly for you all. So I'm going to add here. So within few minutes, the crystals will dissolve and the solution becomes blue. Okay. So this is a copper sulfate solution actually, which I am going to prepare a solution by adding copper sulfate crystals in a water, normal water I took. And so here you can see a copper sulfate solution, a light blue color one, a light blue color you can observe. Okay. So for this, I am going to add, for this solution, I am going to insert an iron nail. Okay. Now you can see an iron nail here. So this is iron nail I am using. Okay. So this iron nail, when I put in a copper sulfate solution, after some time, the iron nail structure will change. The iron nail structure will change. So what actually happens in the reaction? Let us see through a video and then we can check our this one, test tube 2, whether the reaction happened or not. So let us check the video, what experiment or what is the result of the activity, because my activity takes time to happen. Before that, once it happened, we will watch it. Before that, we will watch a video based on it. So this is a displacement reaction which we are going to learn today. 1 minute, let me share it. Fine. So we took copper sulfate and iron. As you can see, copper sulfate is in the box, in that white box, and they took a test tube and they also consider an iron nail. So iron, when reacts with the copper, what happens actually? So iron, what happens? Let me tell you. Just a minute. Okay. So here, iron, what it does, it will take the place of copper from the copper sulfate solution. Means what it is doing? It is taking the place, it is disturbing the place of copper in its solution and becoming ferrous sulfate, and copper is released or will be detached from the copper sulfate solution. For this, iron should be stronger than the copper. Then only it can take the place of the copper. So such a reaction in which an atom displaces other atom from its solution, an atom displaces other atom from its solution, is called as displacement reaction. So let us see how the activity is done and what is the result. So the solution turns green in color before it will be blue in color. When you put iron nail, it will turn into greenish in color. And let us see what happens to a iron nail. So they took 3 test tubes. So I think they will make a solution of copper sulfate. So this is the copper sulfate they are using. So you can see copper sulfate pentahydrated, means removal of water is done. And yeah, it will be blue in color. They will just show you. Yeah, see, it is blue in color. And they are taking the copper sulfate solution using spatula. That equipment is called spatula, not spoon. And they are putting it in the test tube. Okay, now they will add a distilled water to it, so that copper sulfate solution is formed. Fine. So once the copper sulfate solution is formed, we have to stir it so that the salt will dissolve in a water completely. Okay, so this is the copper sulfate solution. Shake it until all the salt dissolves in it. Now take a small portion of that solution in other test tube. Okay, take a small amount of it in other test tube. Fine. Now we have to insert an iron nail in this test tube. So we are going to insert an iron nail in this test tube. Let us see what happens next. So until this we also done now. I also demonstrated it. So look after it. I think my activity should it needs time. So they left it for some time, and now see it when it is left undisturbed. You can see certain deposition on the iron nail. This deposition, just a minute. This deposition, what you're seeing, okay, it is nothing but, this is nothing but a copper which accumulated on the iron, and iron from the iron nail is mixed with the copper sulfate solution. So the solution looks, I think in camera it will not look, it will become pale green in color, and the iron will become, the copper will be deposited on iron, so it will look brownish in color. So this is the reaction called as displacement reaction, where one atom in the reaction displaces the other atom from its solution. This is about the displacement reaction. Fine. Okay. So let us see what happened to our solution. Fine. I think it needs some more time. The copper is getting deposited, but it needs some more time, I guess. So when you observe clearly, you can see a brownish formation on the, yeah, brownish formation on an iron nail. Before it was not like that. Actually, before it was like this. Okay, before it was like this. See the color difference. Before it was like this, now it is looking like this. It is nothing but the deposition of copper occurred, and iron displaced the copper from its solution. So like that, we can get zinc and copper sulfate solution, lead, and we can take a copper chloride solution. So here what is the main thing is, the solution, the atom, the solution in which you are dipping, it should be less, it should be having less strength than compared to which atom you are using to be deposited. Okay, for example, iron is stronger than copper sulfate, so copper, that's why it displaced copper. Zinc is stronger than copper, that is why it displaced copper from its copper sulfate solution. Lead is stronger than copper, that is why it displaces copper from copper chloride solution. Okay, so such reactions are called as displacement reaction. Another one we have when the reaction occurs between certain salts, okay, certain salts, there what happens, there will be exchange of ions completely. So we know that, let us take 1 minute. Okay, so here let me take, okay, so here let us take NaCl. Okay, NaCl. In NaCl, what happens is, just a minute. Okay, NaCl. So in NaCl, what happens here is Na plus will be NaCl, Na plus, it will be having Na plus ions as well as Cl minus ions. Ions are nothing but the charged particles. Ions are nothing but charged particles. So like that, when you take Ki, potassium iodide, it will be having K plus ions, I minus ions. So when such reactions happen, there will be displacement of both the atoms in the solution, both the atoms. Such reactions are called as double displacement reaction. So how the double displacement reaction occurs, let us see now. Just give me 1 minute. So here, okay. So here, observe this activity. So here, what they took is they took test tubes, okay, 2 test tubes, and they took lead nitrate chemical, and they also took potassium iodide. Lead nitrate and potassium iodide, both are the chemicals they took, and they took certain test tubes. Now they are preparing the lead nitrate solution as well as Ki, that is potassium iodide solution. So let us see how they will take. See the color of lead nitrate. You can see the color of lead nitrate is white in color. It is colorless, we can say. So they are taking a pinch of lead nitrate and they are dissolving it in water. In other test tube, they took potassium iodide crystals. So let us see the color of potassium iodide. You can observe that it is also white in color, which is taken in another test tube. Now they are going to make the solution of both the chemicals. See, they are preparing the solution of potassium iodide. So while shaking, you should not use your thumb, you should use your forefinger. That is the rule of using a test tube or shaking the test tube for dissolving. Now they are preparing the solution of lead nitrate. Okay, so both the solutions are ready for the reaction. You can see one is whitish in color, the other is transparent. Lead nitrate is quite whitish in color, milky color, and the potassium iodide is colorless solution. Okay, now they are mixing or they are adding lead nitrate to the potassium iodide solution. Let us see what reaction we will get. See, the color changed. Okay, so the color of the potassium iodide changed. Then what happened there? What chemical reaction happened there? There nothing but the changing of ions takes place where lead iodide and potassium nitrate are formed. Whatever you are getting here, the light orange or yellow color precipitate, it is nothing but the lead iodide and the potassium nitrate. See, potassium iodide, as you can see here, the potassium iodide Sorry, just a minute. See the color. So what happens here is, as you can see, the potassium iodide has K plus ions and I minus ions. And lead has Pb plus 2 ions and NO3 minus 1 ions. So there will be exchange between cations and anions. There will be exchange between cations and anions between the reactant. Means this K plus will react with NO3 minus. This Pb2 plus will react with iodine, that is I minus, to give lead iodide and potassium nitrate. Okay. So this whatever the potassium nitrate is you got, so it will be soluble in water, so you can't see that. But whatever the orange color you can see, that will be lead iodide. Whatever you are seeing, it is precipitated, means you will get a very minute crystal like in the reaction. That is nothing but lead iodide. So this is regarding the displacement and double displacement reaction. Okay, for displacement, we did a demonstration activity. For double displacement, we watched a video based on the activity. So let us see our reaction. Yes. Now you can see clearly the deposition of the copper inside on the nail, on the iron nail. See, completely turned to brown. So this is not rusting. This is a deposition of copper on the iron nail. Let me check. Can I able to get it? Yes. Fine. See, you can see the complete deposition of copper on the iron nail. See it. So this brownish color, what you are seeing, it is nothing but it is a copper. It is copper. Okay. Before it was like this. So you can compare now. See, this is a reacted one. This is the actual iron nail. Okay, the other one, it is like this only I insert it, so you can differentiate now. Okay, so this is the iron nail, and here you can see the deposition of copper. See how different they look actually. See, right? So the deposition of copper. Okay, so this is regarding the reaction of displacement. And in the next session, we are going to learn regarding two more reactions which we are seeing or experiencing in our daily life. Okay, for example, rusting of iron you can see. And if you see some copper vessels, okay, see the bottom of copper vessels if they are not used for many days. So you can see that the greenish patches you can see on the copper vessels. Okay, so why these occur? What is happening actually to those vessels, actually to those metals? That all we are going to learn in the upcoming session. I hope today's session is fruitful. If you have any doubt, you can comment me. You can comment. And so here we are going to end the session. Have a nice day. Bye bye. Take care.